All right, let's jump into another deep dive. Today, we're going to be taking a look at Attention is All You Need,
Okay.
which is a paper from Google AI that really revolutionized machine learning,
Mhm.
especially in language translation.
Yeah.
So I know you all out there listening, you're all about getting to the point and finding those aha moments. And I think this deep dive will deliver just that.
Yeah, definitely.
So let's get right to it.
So this paper is interesting because it tackles this problem that's been plaguing machine learning for a while now.
Okay.
And that problem is how to process language effectively, especially in long sentences.
Okay.
And traditional models like recurrent neural networks or RNNs really struggled with this.
Right. So it's kind of like if you were trying to explain a movie you just watched, but you had to start from the end and
Mhm.
work your way backwards, you'd probably forget a lot of important detail.
Totally. You would totally mix things up.
Yeah.
And RNNs kind of run into the same issue.
Yeah.
So uh, the researchers behind Attention is All You Need
Hmm.
realized this and decided to ditch RNNs entirely.
Okay.
And they came up with a solution called self-attention.
Okay. And that's where the title of the paper comes in, right? Attention is all you need.
Exactly.
That's a pretty bold statement.
It is. It is.
But it looks like they were able to back it up
Yeah, it
with
is.
some amazing results.
Exactly.
So what does this self-attention do?
So self-attention lets the model focus on the most important words in a sentence,
Okay.
regardless of where they are in the sentence.
Bro.
It's kind of like how our brains naturally filter out noise and focus on the key points in a conversation.
Okay.
Self-attention lets the model do the same thing.
Okay.
And that makes it way more efficient and accurate, especially with longer sentences.
Okay, I think I'm starting to get the concept, but how does it actually work? This self-attention magic.
Right.
It sounds a little too good to be true.
So at core of self-attention is something called scaled dot product attention.
Okay.
Now, stick with me here. It's not as complicated as it sounds.
Oh, great.
Okay, so imagine we have three key players. We have queries,
Okay.
we have keys, and we have values.
Okay, so I'm picturing a librarian
Okay.
who's helping me find a book,
Okay.
and I tell them what I'm interested in, that's my query.
Mm-hmm.
The library catalog with all the titles and topics, that's like the keys.
Yeah.
And then the books themselves, the actual information, are the values. Does that kind of track?
That's a great analogy.
Okay.
You're exactly right. So the query is essentially what the model is looking for
Okay.
at a specific point in time.
Okay.
The keys are like tags or labels attached to different parts of the input sentence.
Okay.
And the values are the actual information that's tied to those keys.
Gotcha. So it's like the model's using the query to kind of search for the right keys and then pull up the values.
Yep, you got it.
So it's like a super efficient search engine for language.
Exactly.
That's really cool.
Yeah.
This is already sounds pretty revolutionary.
Yeah, and
Yeah.
by calculating how well the query matches each key, the model can then assign weights to the different values.
Okay.
And those weights then tell the model which parts of the input are the most important
Okay.
and deserve more attention.
So it's not just processing words in order anymore.
Right.
It's actually understanding how they relate to one another.
Exactly.
Okay. And then focusing on the important parts.
Yeah.
I can definitely see why this is such a big deal.
And then the paper actually showed
Okay.
how impactful this was because models that are built with self-attention achieved state-of-the-art results in translation quality.
Wow.
And they even outperformed these massive, computationally expensive models that relied on older methods.
So it seems like attention really was all they needed.
It seems that way.
Okay, so they really nailed it with this self-attention, but I'm guessing they didn't just stop there.
No, they didn't.
The paper also mentions something called multi-head attention.
Exactly.
Like, what's that all about?
So think of multi-head attention like having a team of experts,
Okay.
all analyzing the same sentence,
Okay.
but each focusing on a different aspect.
So like getting multiple perspectives to get a better understanding.
Exactly, exactly.
Okay.
So each attention head might be looking for something different. Like one might focus on grammatical relationships, while another is trying to understand the meaning of the sentence as a whole.
Okay, and this is kind of like in figure 2 of the paper, right?
Yeah.
Where it shows these different attention heads focusing on different parts.
It's a great way to visualize what's going on.
Yeah, and I think, like, having a visual like that really helps to understand it.
It does, because otherwise it's very abstract.
Yeah.
So, yeah, you need something to ground it.
Yeah, so it's like having this team of experts, right? Like
Yeah.
detectives piecing together clues to solve a case.
Yeah, that's a great way to put it.
So by combining these different viewpoints, the model can get a more complete picture
Right.
of the text. This is
That's
really fascinating stuff.
it is.
Um, I'm curious though, like why is this multi-head attention so important?
Okay.
Like, did it actually improve on the results they were already getting with just the basic self-attention?
Yes, it did.
Okay.
Because multi-head attention allows the model to capture a wider range of relationships and dependencies
Okay.
within the text.
Okay.
And, language is super complex.
Yeah.
There's layers of meaning,
Right.
subtle nuances, different ways to interpret the same words. So, yeah, it's really
So
important.
it's not just understanding individual words, but how they relate to one another
Exactly.
and how that all contributes to the overall meaning.
Yeah.
Wow.
And multi-head attention provides a powerful way to do that.
Very cool. Um, I I have to ask though, like, how did they even come up with this idea? Was there anything in previous research that kind of pointed them in this direction?
Yeah, that's a really good question.
Yeah.
So the idea of attention itself wasn't entirely new,
Okay.
but the way they implemented it in this paper was definitely groundbreaking.
Okay.
So they drew inspiration from different areas,
Okay.
including computer vision and cognitive science.
So they were able to connect these like seemingly unrelated fields
Mhm.
and then come up with this like totally new innovative approach.
Exactly. Yep.
That's really cool and the results speak for themselves, right?
Completely, yeah.
The transformer, which is what this model is called,
Mm-hmm.
has really changed the game for machine learning.
Yeah. Yeah.
Okay, so we've talked about
All
self-attention.
right.
We've talked about multi-head attention.
Yep.
We've, touched on the amazing results of the transformer.
Mm-hmm.
But, this is the deep dive.
Right.
So let's dive a little deeper here. I'm curious about the specific advantages of this new approach.
Yeah.
What makes it so much better than the old ways of doing things?
Sure. Well, one of the big advantages is that self-attention is much faster to train than those older recurrent models.
Okay.
And that's a big deal in machine learning
Yeah.
because training these models can take like days or even weeks
Wow.
and a ton of computing power.
Right.
So if you can get the same or better results in less time
Yeah.
with less computing power,
Yeah.
that's a huge win.
Right. So it's not just about accuracy, it's also about efficiency.
Exactly.
Well, that makes sense.
But there's another advantage that I think is even more exciting.
Okay.
And that is that self-attention can handle much longer sentences
Okay.
than traditional models.
Right. Yeah.
Remember that movie analogy we talked about earlier?
Yeah.
Imagine trying to explain like the plot of a whole trilogy
Oh, wow.
in reverse.
Yeah.
RNNs would like totally have a meltdown.
Right.
But self-attention can actually keep track of all those important details,
Okay.
even in those really long sequences.
That's pretty amazing.
It is, yeah.
So it's like the model has a better memory or something.
Yeah, it can see the bigger picture.
Right.
Even when you're dealing with a ton of information.
But how do we know that this is actually better?
Yeah.
Like, how do we measure that?
Right.
The paper mentions something called BLEU scores.
Mm-hmm.
Can you explain what those are?
Yeah, so BLEU stands for Bilingual Evaluation Under Study.
Okay.
And it's basically a way to measure how good a machine translation is.
Okay.
So it compares the machine translation
Okay.
to a bunch of high-quality human translations
Okay.
and gives it a score based on how similar they are.
Gotcha. So it's like a judge at a translation competition.
Exactly.
Higher score, better translation.
That's it.
Okay.
And the transformer, using self-attention, achieved significantly higher BLEU scores
Wow.
than any other model before it
Okay.
for both English to German
Mm-hmm.
and English to French translations.
Okay, that's really impressive.
Yeah, it was groundbreaking.
Okay, so higher score, better translation. Got it.
Yeah.
The paper also mentions something about training cost.
Right.
What does that mean?
So training cost is basically all about the resources that you need
Right.
to train a machine learning model.
Okay.
So we're talking about, computing power, memory, time,
Right.
all that stuff.
Right.
And the more complex the model is, the higher the training cost.
Okay.
And these resources are they're not cheap.
Right.
So it's kind of like finding a car that's both powerful and fuel efficient.
Okay.
You want something that can get the job done without breaking the bank.
Right. That makes sense.
And that's another area where the transformer really shines. Because
Okay.
it can be trained much faster than those older models, using less computing power and less time.
Okay.
So, it's not just smarter, it's more economical.
Right.
Yeah.
That's awesome.
Um,
But did they just like stumble onto this perfect architecture by chance? Or did they like try different things to see if they could improve it?
that's what I love about this paper.
Okay.
They actually did a ton of experimenting.
Okay.
There's a whole section in the paper that's dedicated to model variations,
Okay.
where they tweaked different parameters and components
Okay.
to see how it affected performance.
So they weren't just like randomly changing things.
No.
No.
Had a plan.
They had a plan.
Okay.
They had specific hypotheses about what might improve the model,
Okay.
and then they systematically tested those hypotheses.
Okay.
So, for example, they played around with the number of attention heads,
Okay.
the size of the keys and values,
Okay.
and even different ways of encoding the position of words in a sentence. Okay, so they were really trying to like understand not just what worked, but like why it worked.
Yeah.
Like true scientists.
Yeah. Yeah.
What were some of the interesting things that they found?
So they found that bigger models generally performed better.
Okay.
No surprise there.
Right.
But they also found that dropout, which is a technique to prevent the model from memorizing the training data too closely,
Okay.
was extremely helpful.
Okay, that makes sense.
Yeah.
What about those other experiments,
Yeah.
like changing the number of attention heads or
Right.
tweaking the size of the keys and values? Did any of that like lead to big improvements?
Yeah. So they actually found that reducing the size of the attention keys
Okay.
had a negative impact on the model's quality.
Interesting.
And this suggests that figuring out how well a query matches a key
Yeah.
is a pretty complex task.
Okay.
And a simple dot product might not be the best way to do it.
Okay, so even though they came up with this like really amazing approach, there's still room for improvement.
Always, yeah.
Okay.
And that's what's so exciting about research like this. It opens up these new avenues for exploration.
Right.
And it pushes the boundaries of what's possible with AI.
Okay, so we've covered a lot here. We've
forgotten
gone
a bit.
from the limitations of those traditional models to this this really elegant self-attention, the amazing results of the transformer, and
Yeah.
even some of the really like nitty-gritty details of their experiments. But I kind of want to step back for a second
Okay.
and think about the bigger picture.
Go ahead.
Like, where does this all leave us?
Yeah.
What's the main takeaway for someone who's not a machine learning expert?
Right. So I think the big takeaway is that
Yep.
attention-based models are really changing the way we think about
Okay.
and build and interact with AI.
Okay.
They're making AI more powerful,
Okay.
more effective, and even more human-like in its ability to understand and process information.
So it's not just like a technical breakthrough.
Right.
It's like a fundamental shift in how we think about the possibilities of AI.
Exactly. Yeah.
Wow.
And this shift is going to have a profound impact on our lives
Okay.
in the years to come.
Okay.
We're already seeing the early signs of this.
Okay.
In areas like virtual assistants, language translation,
Yeah.
and even medical diagnosis.
That's incredible.
Yeah.
To think about all the potential applications.
It is.
It's like we're on the verge of this whole new era of AI powered innovation.
Very exciting.
Yeah, but we got to be realistic too,
Oh, yeah.
right?
Yeah.
Are we talking about things that could happen in the next few years, or is this more like a long-term vision?
That's a great question.
Yeah.
While some of these applications are already starting to emerge,
Right.
others might still be a few years away.
Okay.
But, the pace of innovation in AI is accelerating.
Yeah.
So who knows what the future holds?
Right. I guess that's part of what makes it so exciting. Like,
Yeah.
The possibilities are kind of endless,
Mhm.
but we also have to be mindful of the risks, right? And the challenges
Yeah.
that come with such powerful technology.
You do. You have to be very thoughtful
Yeah.
about how we develop it
Yeah.
and how we use it.
Okay, well, let's get back to the paper for a second.
Okay.
We've talked a lot about like the successes of the transformer.
Mhm.
Were there any areas where it struggled?
Yeah, that's a good question.
Yeah.
So while the transformer was incredibly successful,
Mm-hmm.
it wasn't without its limitations.
Okay.
One challenge was that self-attention can be computationally expensive
Okay.
for very long sequences.
Right. So like those
Remember those
really long movie trilogy?
Davy trilogies? Yeah.
Yeah.
Even the transformer has its limits when it comes to processing, huge amounts of information.
So there's kind of a trade-off then
There is.
between accuracy and efficiency.
Yep.
The more information you feed it,
Mm-hmm.
the more resources it takes to process it.
That's exactly right.
Okay.
Another challenge was that the transformer, in its original form,
Okay.
wasn't very good at handling tasks that required understanding the order of events. If you're trying to translate a sentence
Yeah.
that involves a series of actions,
Yeah.
the transformer might struggle to capture the temporal relationships
Right. Okay.
between those actions.
So if the model is mostly focused on the relationships between words,
Yeah,
it might miss some of the nuances that come from the order
yeah,
that they appear in.
that's exactly right.
Okay.
But that's the beauty of research.
Yeah.
It's an ongoing process
Yeah.
of discovery and improvement.
Right.
And even though the transformer had some limitations,
Mm-hmm.
it provided a foundation for countless other researchers
Right.
to build upon.
So it was a starting point, not an ending point.
Exactly.
Yeah. Okay. I like that. So it sounds like, attention is all you need was a huge turning point
Yeah,
for AI.
it was.
But the story's not over.
No, not at all.
So, like, what are some of the most exciting directions that researchers are exploring now? What's next for attention-based models?
Well, one area is something called sparse attention.
Okay.
And remember how we talked about the transformer struggling with those really long sequences?
Yeah.
Because of, computational costs.
Mm-hmm.
So sparse attention basically aims to solve that
Okay.
by allowing the model to focus on only the most relevant parts of the input
Okay.
instead of having to attend to every single word.
So it's kind of like a more selective form of attention.
Exactly.
Like how our brains can, filter out distractions.
Yeah, exactly.
Right.
And this has the potential to make attention-based models
Okay.
way more efficient and scalable
Okay.
so that they can handle even larger and more complex data sets.
Okay, so that opens up a lot of possibility.
It does.
What about those limitations we talked about before?
Yeah.
Like the transformer's difficulty with understanding the order of events.
Right.
Are researchers working on that too?
Absolutely. There's a ton of research going on right now
Okay.
that's focused on incorporating more explicit mechanisms
Okay.
for handling sequential information
Okay.
into attention-based models.
Okay.
So, for example,
Mm.
some researchers are experimenting with hybrid models
Okay.
that kind of combine
Okay.
the strengths of self-attention
Mm-hmm.
with the sequential processing capabilities of RNNs.
So like taking the best of both worlds.
Exactly, yeah.
Okay.
Combining the efficiency and long-range dependencies of self-attention
Oh.
with the ability to understand those temporal relationships.
Very cool. And this is like just the tip of the iceberg, right?
It is, yeah.
Okay.
Researchers are also exploring ways to make attention-based models more interpretable,
Okay.
more robust to noisy data,
Mm-hmm.
and even more capable of learning from limited data.
It sounds like the field is like exploding with new ideas.
It is, and it is.
And innovations. It's pretty amazing to think about how much progress has been made
Yeah,
since this paper came out.
it really is.
So to bring it all back to our listener out there,
Yeah.
what's the one big takeaway from all of this? Why should they care about this? Attention is all you need paper,
Right.
And the revolution that it sparked.
I think the biggest takeaway is that attention-based models are changing the way we build and interact with AI.
Okay.
They're making AI more powerful, more efficient,
Mm-hmm.
and even more human-like
Okay.
in its ability to understand and process information
So it's not just a technical breakthrough,
Right.
it's really a fundamental shift
Yeah.
in how we think about AI.
Exactly.
Okay.
And this shift is going to have a huge impact on our lives in the years to come.
Okay.
We're already seeing the early signs of this
Okay.
in areas like virtual assistants,
Mhm.
language translation, and even medical diagnosis.
It's incredible to think about all the potential applications of this technology.
It really is.
Like we're at the start of something really big.
Yeah, we are.
But as we discussed,
Yeah. Wait.
it's important to proceed thoughtfully and
Absolutely.
responsibly.
Yeah.
We really need to make sure that this technology is used for good
Mm,
and that it benefits everyone.
I completely agree.
Okay.
Yeah, the future of AI is in our hands,
Yeah.
and it's up to us to shape it in the way that's beneficial and equitable for all.
Well said. Well, this deep dive has been incredible.
It has been.
We've gone from the inner workings of self-attention
Right.
to the really far-reaching implications of this technology.
Mm.
It's amazing to see how one paper can spark
Yeah,
such a huge wave of innovation
it really is.
and change.
Yeah,
So it's been a real pleasure exploring these ideas with you.
it has been.
I hope you listening out there, found this deep dive as thought-provoking as we have.
I hope so too.
And if you're feeling inspired to learn more,
Yeah,
I definitely encourage you to check out the original paper.
yeah, it's a great read.
Attention is all you need.
Mm.
It's a fascinating read, even if you're not a machine learning expert.
Absolutely.
But for now, we're going to wrap things up.
Okay.
Thanks for joining us on this deep dive.
Thanks for having me.
And until next time, keep exploring.